Welcome to Math 104, Chapter 2AT. This is our intro to Chapter 2, where we talk about linear models, equations, and inequalities. So what we're going to be focusing on is fractions, because you will see fractions, and I know you have a calculator, but we have to be able to feel comfortable enough with fractions where if we see them, we can kind of make a choice. Can we try and do this by hand versus a calculator, or perhaps you forget a calculator at home? So it says when multiplying fractions, we multiply top to top and bottom to bottom. So multiplication, very, very nice. We're just going to multiply straight across. So 2 times 4 is 8. 5 times 3 is 15. So multiplying straight across, no sweat. Since something like this, again, we can multiply straight across. So we have negative 14 over 24. Now in this case, this is a little special because what do 14 and 24 have in common, right? So we can do this by breaking up your 14 and your 24 by some factors, right? Making a little factor tree. But good rule of thumb, if they're both even, we can determine that they both have a 2 in common. So 2 times 7 make 14, or 2 times 12 make 24. Now, when we go ahead and cross out those 2's, whatever is left over will be our fraction, negative 7 over 12, and then we can reevaluate. Do 7 and 12 have anything in common? No. So we can reduce once we can multiply first and then we can reduce, or a little cheat way, which I'm sure maybe some of you have seen before. If you notice that the numbers directly across have something in common with each other, we can actually cancel out to start. This is a little bit easier because as you see, your numbers get a little bit bigger here versus to start, they're pretty small. So I do recommend perhaps canceling out to begin with. So I'm just rewriting our problem here. Okay, so do 7 and 3 have anything in common? No, but 8 and 2 certainly do. 8 has 2 times 4, which we can then cancel out those 2's, and that 4 is left behind. So we have negative 7 times, and anything that you cancel is just kind of a placeholder of 1, 4 over 3, and now we can multiply straight across. So you have equals negative 7 over 12. Now those two should match as long as you've done them correctly. So I would say as best you can, just try and recognize if there's something to the diagonal, we can then try to cross it out. Now let's say we're trying to multiply a fraction by a whole number. We saw in our last lecture, we can just put this whole number over 1 and then treat it as a fraction. Multiply straight across. So negative 3 times 9 is a 27. Those negatives cancel. 2 times 1 is 2. Now do 27 and 2 have anything in common? No, so we can stop. So big takeaway, multiplying fractions is the easiest way. We're just multiplying top to top, bottom to bottom, and evaluating if your fraction needs to be reduced. All right. Now we actually just did this part just a moment ago, but let's give it some practice as well. So let's see if, and don't worry about method 1, method 2, you just determine, do you want to do this part up here or this part down below? So let's say we did not remember to reduce a little bit. So instead we're going to multiply straight across. So 21 times 6 is going to be 126. 7 times 10 is 70. Okay, so these both have a 2 in common. They are both even. So 2 times what equals 126, or 126 divided by 2 gives us 63. Same thing. 2 times what gives us 70, or 70 divided by 2 gives us 35. So we can cancel out these 2's because they have that in common. Then we can keep going. 63 over 35. Now, do 63 and 35 have something in common? Well, they're not even, and since 63 does not end in a 5, they don't have a 5 in common, but they do have kind of an unusual number. They both have a 7 in common. 7 times 5 gives you 35, and 7 times 9 gives you 63. So we can cancel these values out, and then we get 9 over 5. So there's a lot of reduction going on if you don't hit it immediately. That just means they have to start a 2 and a 7 together, or even better, or even more of a 14 together. Now let's practice your other method. So let's look at trying to cancel out to start. So let's look at 6 and 10. So what do 6 and 10 have in common? Well, these have a 2 in common. So 2 times 3 and 2 times 5. We can cancel these values out and leave behind a 3 and a 5. Now let's try it again for 7 and 21. 7 has just 1 and 7, and 21 has 3 times 7. And we're just going to be canceling out the 7s. So your new fraction is 3 over 1 times 3 over 5, where we're going to multiply straight across now and get 9 over 5. And there you go. Now that's if we multiply fractions. Now let's take a look at dividing fractions. While it might look intimidating at first, dividing fractions is just almost identical to multiplying fractions. There's just one added step. So dividing fractions is similar to multiplying, but with one extra step at the very beginning. First, we flip your fraction. The bottom fraction, so it's always the bottom fraction that you're going to flip, or if you're like here, it's always going to be the fraction to the right. This is referred to as keep, change, flip. Dividing fractions is the only time that we flip a fraction. So if we're given something like this, if we wanted to rewrite this problem, we can also represent it as negative 55 over 18 divided by 25 over 4. So when we say keep, change, flip, it's always referring to this bottom one or to the very, very right. And what that means, I'm just going to rewrite the first fraction. It means keep the sign. So if you're 25 over 4, if it's positive, we're going to keep it positive. You're going to change the operation. So instead of division, we're going to multiply, and then we are going to flip your fraction. So instead of 25 over 4, it's now 4 over 25. Now let's see if we can reduce a little bit, or if you want to just multiply straight across, that is all right as well. Let's say you wanted to multiply straight across. Well, actually, no, good habits, good habits. We did talk about it being a little bit easier to reduce at the beginning. So 2 times 2, 2 times 9. Let's see, we have 5 times 5 and 5 times 11. So canceling out a 2 and a 2, a 5 and a 5. So we have 11 times 2 over 9 times 5, which is 22 over 45. And that's actually a negative because of your negative here. All right, let's try it again with the next one. So I would say pause the video, try it out yourselves, see what you can come up with. So we can rewrite this one, 3 over 2, keep, change, flip, 3 over 5. And now multiplying straight across, we get 9 over 10. Try it again. Lots of students think that, see it as -3 over 1. That is perfectly fine. I was always taught that this is actually the numerator of the bottom value here. It really doesn't make a difference. So we're going to rewrite your top fraction. Then we're going to keep, change, flip, -1 over 3. And multiply straight across, -14 over 15. All right, so that is dividing fractions. So now let's do something slightly harder where we are now adding and subtracting fractions. So we can add and subtract fractions when we have a common denominator. So notice that your bottom fractions below, they both have a 25 in common. So now we're just asked to subtract your numerators. So we can actually go ahead and subtract 72 minus 64. And because they have a common denominator, this is all over 25, which means when we subtract, we'll just get 8 over 25. And since that doesn't reduce, we would be done. However, when we do not have the same bottom number, we have to work to find something called the least common denominator, the LCD. Have you heard that before? Well, think about something like 1 over 2 plus 1 over 4, right? Your least common denominator says, hey, find the smallest number that they have in common. So 2 and 4 have a least common denominator, right? The smallest value, can 2 go easily into 4? Yes. So since 4 is itself the least common denominator between the two would be 4. Other common denominators, right? 4 can't easily be changed into 2. So instead, 2 has to raise up to 4. But other common denominators, think about what else a 4 and a 2 can become, can come together, right? They can both be made into 4s. 4 times 2 is 8. 2 times 4 is 8. Let's see, 2 times 6 is 12. 4 times 3 is 12. We could also do it again. Let's see, 4 times 4 is 16. 2 times 8 is 16. So these are all values, and these can keep going. These are all values that they can both of these numbers can be made into a 4, 8, 12, 16. But the smallest one possible is 4. Now we always want to go with the smallest one because it's going to be less work for us to reduce. So typically we can multiply both numbers together. So before, notice that we did not multiply 2 and 4 together to get 8, right? 8 is one of your common denominators, but it's not the smallest. So 4 being the smallest, we just had to multiply one of your two fractions to get it to fit. Now, if that is not the case between 3 and 4, well, what's the least common denominator that they can share? Well, the smallest value or the smallest denominator that they can both be is 12. So then how does this 3 transform into a 12? By multiplying it to 4. Now what you do to the bottom, you also have to do to the top. So 4 times 2 is 8. 4 times 3 is 12. So this fraction here is the most reduced fraction. This fraction here does have a 4 in common. We can say plus, and now let's do the same thing, but 4 has to be made into a 12. So what would you multiply it by? We'd be multiplying it times a 3. What you do to the bottom, you do to the top. 3 over 12. And now that they share a denominator, we can then add your values in your numerator. Now let's try it again with the following. So I would say pause the video, see if you can try the next two. All right, so 5 and 25, kind of like what we did with the 1/2 and the 1/4. This 5 can easily be made into a 25 by multiplying by 5. 4 times 5 is 20 over 25 minus 4 over 25. Going ahead and subtracting the two, we have 16 over 25, which they do not share anything in common and is considered fully reduced. Okay, so we have a lot going on here. So we are trying to figure out what is the smallest number that these share. And I did not actually write it over here. Your LCD is 25. Your LCD here is what number? Well, if you're unsure, we can always list what 3 can be made into. So 3, 9, 12, 15, and so forth. Same thing here. Let's see, 10, 20, 10, 20, 30, 40, 6. We can do 6, 12, 18, 24, 30, and so forth. So what can be the smallest denominator possible? Well, I didn't write out all from the 3, but notice what your 10 and your 6 have in common, right? Well, they both have a 30 in common, which means can 3 be put into a 30 pretty easily? Yes. So that one can be made into 30 very, very quickly. So 3 times what can be 30? 10. 10, how does 10 become a 30? Multiplying it by 3, and 6, multiplying it by a 5. So you have 20 over 30 plus 21 over 30 plus 5 over 30, which we can now add all of your numerators to get 46 out of 30, which these are both even numbers, so they do share values in common. So we can reduce that to 23 over 15. So that is adding and subtracting fractions. Now, how does that relate to what we are doing? Well, we are taking a look at solving equations. We're going to be seeing some near fractions. So if you know how to do these, I would just say pause the video and give these a shot. So in your first one with solving, we are trying to get x all alone and to one side. By doing so, we want to definitely divide any coefficients that x has. So we can divide each side by 3. So 6 divided by 3 is 2. Now we can always check your answers by subbing that 2 back into the equation and hoping that a 6 comes out, which it does. And trying it again here. Now if we're having your x being divided by a 5, the opposite of division is multiplication. So we can multiply both sides by 5. That'll cancel out with the 1 over here. And x is equal to 60. Again, you can double check by getting 60 divided by 5, which is equal to 12. So that works out. Now, if you have something added or subtracted, we definitely want to take care of that first. Otherwise, if you're trying to divide everything by 3, it's not just dividing these values by 3 here. It has to be equal. If you divide one value by 3, you have to do it to your other terms. So to make it a little bit easier for yourself, we can always add or subtract things to the other side first so that we can isolate this x just like it was isolated in our previous two problems. 3x is equal to 12. Now we can go ahead and divide both terms to one side. Last but not least, you might see it where you have multiple variables, but they are the exact same variables, and we want to work to get them to the same side. So one thing we can do is try and get 8 to the other side. That matches with your 4. So you have 5n is equal to 3n plus 12. And then perhaps we subtract your 3n to the other side. Combining your like terms like we did from, I want to say that was like chapter, that was probably one of our very first sections actually. 2n is equal to 12, and then you can divide by your 2. Always double check your work, make sure it makes sense. So we have 5 times 6 minus 8 is equal to 3 times 6 plus 4. So we have 30 minus 8 is equal to 18 plus 4, which checks out. All right, and I believe that is it. We are going to be seeing lots of fractions in our next section, so make sure you feel comfortable working and manipulating with fractions.